for solving log equations, the first thing that you have to remember is the definition of a log, and we've been using this a lot. It's the fact that y equals log base a of x means x equals a to the y power. Recall there that a has to be greater than 0 and a cannot equal 1 because that was the requirements for an exponential function y equals a to the x power. Now this property down here we were exposed to as well. That's the one-to-one property for log functions. It basically says if you have two logarithmic expressions that are equal to each other where they have the same base, in this case a, then the arguments are going to equal each other. So if log base a of m equals log base a of n, then it must be the case that m equals n. Again, a must be greater than 0, a cannot equal 1, and both m and n must be positive because that's the domain restriction on your log functions. So with those ideas in mind, we're going to go through and solve a few log equations, and then we'll look at solving some exponential equations later. So here we have 4 times log base 6 of x equals log base 6 of 16. You should notice that we have a log on each side of the equation, and the base of the log is 6. However, we have a coefficient out in front of the log expression on the left. So we're going to use the fact that r times log base a of m equals log base a of m to the r power, and rewrite the expression on the left is log base 6 of x to the 4th power equals log base 6 of 16. So now we can use the fact that if log base a of m equals log base a of n, then m must equal n. So I can set each of the arguments equal to each other, and I get x to the 4th equals 16. Now take the 4th root of each side of the equation, and you get that x is plus or minus the 4th root of 16, which is plus or minus 2. Now it's super important that you always check your answers to make sure that they are reasonable, and also check to make sure that the value of x is in the domain of the original function. Up here on the left, we know that x must be greater than 0 because the domain of any log function is such that the argument must be positive. Because x must be greater than 0, -2 is an extraneous solution and therefore is excluded from the solution set. So your solution set is only 2. So in this problem, the two takeaways are: use your property of logs to isolate each log so that you can set the arguments equal to each other. And secondly, make sure you check your answers to make sure that any solution is in the domain of the original expression. And then here we're just checking our answer to make sure that 2 is in fact a solution.